Bismillahirrahmanirrahim. Assalamu alaikum students. I am your physics teacher. I have already shared, actually I first formed the WhatsApp group. You must join that. I have shared the syllabus for your course, for your physics course. I will give introduction in this lecture. So your syllabus comprises of 4 units and it is all about mechanics, right? You are familiar with mechanics. Now I will give introduction and we will start with unit first of the syllabus, right? So I will be giving introduction in this particular lecture. You know, mechanics is that branch of physics which deals with the study of motion of objects, right? So in mechanics we study the motion of objects. Then you also know that mechanics has two sub branches. One is kinematics, second is dynamics. And you know, in kinematics, what we discuss, kinematics is about description of motion, right? So we describe motion in kinematics, and dynamics deals with causes of motion, right? In description, what we do, as you're familiar with, in your class 11th, you have done it thoroughly. In description, we define certain kinematic variables. What are kinematic variables? Kinematic variables are, you have position, displacement, velocity, acceleration. These quantities are called kinematic variables. Now, motion have types. Every motion has its description. You can describe motion in terms of these kinematic variables by specifying, for example, how position, velocity, acceleration of the in the motion changes with time, right? You can have equations of motion for a particular motion, or you give description in terms of graphs. So description can be through graphs or through mathematical equations. But in both cases, your description will be in terms of these particular kinematic variables, right? Now in dynamics, on the other hand, we discuss causes of motion. If something is moving some way, why is it moving that way, not other way? We discuss those causes, and those causes are answered by Newton's laws of motion, mainly Newton's laws of motion. So in other words, in dynamics, we discuss Newton's laws of motion, right? And you know, motion can be one-dimensional, can be two-dimensional, can be three-dimensional. One-dimensional motion means motion is confined along a straight line. So motion in a straight line, motion in a straight line is one-dimensional motion. Straight line can be vertical, it can be horizontal, it can be any way, but if motion is confined along a straight line, motion is one-dimensional, and in one-dimensional motion, you know, to specify the position of a particle or a body, you need only one position coordinate. Two-dimensional motion means motion in a plane. Motion in a plane. For example, XY plane. Now, if motion is confined in a plane, two-dimensional plane, then motion is two-dimensional. Now, in two-dimensional motion, to specify the position of a particular body, you need to specify two position coordinates, right? So you will have two position coordinates for position. Motion can be along a curve, but that curve will lie in the plane, right? Examples of two-dimensional motion are circular motion is a two-dimensional motion because body is moving along a curve which can be superimposed on plane. Projectile motion is another example. You know, in projectile motion, this was circular motion. You can have projectile motion. You have discussed these motions already. You know these motions. In projectile motion, body moves along a parabola, and parabola is a curve which can be superimposed on a two-dimensional plane. Then you have three-dimensional motion, and three-dimensional motion, you know, is motion in space. You know that space is three-dimensional motion. X, Y, and Z. So the body moves in space, then body will be moving in a three-dimensional curve. That curve cannot be superimposed on two-dimensional plane. If you superimpose one portion of the curve on the two-dimensional plane, other portion will remain out of the plane, right? And in three-dimensional motion, you need to specify three position coordinates to specify the position, right? So motion in a straight line is the simplest one, right? Now in motion in a straight line, we have position, for example, x, then we have velocity, then we have acceleration. Now in two-dimensional motion, you will have two positions, x and y. Then you will have two velocities, velocity along x, velocity along y, right? And accordingly, there will be acceleration along x direction, acceleration along y direction. In three-dimensional motion, you will have x position, y position, z position, velocity along x, velocity along y, velocity along z, acceleration along x, acceleration along y, acceleration along z, right? Now, in one-dimensional motion, we don't use vectors. We don't require vectors, but in two and three-dimensional motion, our description becomes easier when we use vectors, right? You also know that when we talk of mechanics, we talk of classical mechanics. Classical mechanics is that mechanics in which we discuss mechanics using Newton's laws of motion, right? So classical mechanics is all about Newton's laws of motion. When we use Newton's laws of motion to discuss mechanics, we say we are studying or dealing with classical mechanics, right? Now you know that classical mechanics has succeeded everywhere in making predictions. We have developed things using classical mechanics, but we have also found situations where this classical mechanics fails to make right predictions about systems. For example, if you know speed of light in vacuum is c, which is a very huge number, 3 into 10 is by 8 meter per second. You also know that the speed is the speed limit of this universe. This is the speed limit of this universe. No particle can exceed this speed, or no signal can exceed this speed. So this is the speed limit, right? Now, if the we're saying that classical mechanics, Newton's laws of motion fail in certain situations, I'm specifying the situation. I'm taking the example. If the velocity of a body is comparable to c, that means a body is moving fast enough. Its velocity is compared to c. Then Newton's laws of motion fail to make predictions about that body, right? So we have another mechanics. Albert Einstein in 1905 extended Newton's laws of motion, extended classical mechanics to these situations also, where velocity of the body is comparable to speed of light in vacuum, right? And that extended theory is called spatial theory of relativity, right? So spatial theory of relativity makes correct predictions about the system or body if it is moving with a velocity comparable to c. But Newton's laws of motion fail there. But spatial theory of relativity in ordinary circumstances, that means when v is small compared to c, reduces to Newton's laws of motion or classical mechanics. That means it is more general theory, spatial theory of relativity. Classical mechanics is less general. Now, other example where Newton's laws of motion fail to predict, right? What is that example? If we are dealing with the motion of very small particles, small particles or subatomic particles, Very small particles are subatomic particles, right? Like electrons, protons, etc. Now, Newton's laws of motion fail to predict. They don't make right predictions. So there we have also extended our theory. We have developed a new theory, that is quantum mechanics, right? So quantum mechanics deals with or makes right predictions about the motion of very small particles, subatomic particles like electrons, protons, right? And it is also extended version of Newton's laws of motion or classical mechanics, and it also reduces to classical mechanics and ordinary situations. Now, this was about mechanics introduction. You also know when we talk of physics, we'll go to now the basic definition of physics. When we define physics, we sometimes say it is study of nature, right? Or more precisely, you can say that it is the study of laws of nature, right? Now, in our universe, different phenomena occur, different events occur, but all those events or phenomena occur in accordance with certain laws, which we call laws of nature. So when we study these laws of nature, we say we're studying physics. And you also know that these laws of nature we express in the form of an equation. For example, we have one such law. We know that Newton's law of universal gravitation, which says if you have 2 point masses m1, m2 separated by distance r, there is attractive force between them. If that attractive force has magnitude F, then this F is G m1 m2 by r square. G is the universal gravitational constant with value 6.67 into 10 raised by minus 11 Newton meter square per kilogram square. We have expressed this law in the form of an equation. It's just an equation. It has left hand side, it has right hand side, just like y is, for example, 2x. Any equation related to certain variables, it has left hand side, it has right hand side. Now, this law we have expressed it in the form of an equation. Now, equation involves variables. Force is a variable, masses are variable because they can have different values, and distance between the masses is another variable. G is constant. Now, these variables which appear in the laws of physics and the equations expressing the laws of physics, these variables we call physical quantities, right? They are physical quantities. Now, these physical quantities, sometimes we refer to them as building blocks of physics. How? Because by connecting these physical quantities, we construct laws of physics, and study of laws of physics is study of laws of physics is physics. Study of laws of nature, sorry, is the study of physics. We said the study of physics is the study of laws of nature. Laws of nature are simply equations expressing the relation between these physical quantities. So physical quantities are building blocks of physics. Now, these physical quantities can be broadly classified into scalar physical quantities, or simply we call them scalars, or and vector physical quantities, or simply vectors. You know the examples here. Scalars example is distance, speed, work, power, etc. Examples of vectors: velocity, displacement, right? Velocity, displacement, acceleration, right? Torque, etc. Now these scalar physical quantities behave just like numbers. There is no involvement of geometry in scalar physical quantities because they have only magnitude. They are specified by only magnitude. There is no direction involved, so they behave like numbers. You can add, subtract them just like numbers using ordinary rules of algebra. But in vectors, there is involvement of direction. They are specified by magnitude and direction, due to which there is involvement of geometry. You cannot add, subtract them by using ordinary rules of algebra. You cannot treat them simply like numbers. So there are separate rules for handling vectors. That is our first topic. We have to discuss, or we have to revise, you know it, we have to revise vector algebra, right? So you go through rules of vectors. I will discuss them in next lecture. This was a simple introduction to your course. Don't miss your classes. Be sincere with your studies. I will give you some homework. Simple homework. We have a simple question. Question 1. A certain spaceship has a speed of 19200 mile per hour. What is its speed in light years per century. I repeat the question. A certain spaceship has a speed of 19200 19,200 mile per hour. What is its speed in light years per century? We have to just convert the speed from mile per hour unit to light years per century. We have to convert this mile. Mile is a unit of distance. Light year is also a unit of distance. Light year is what? Distance traveled by light in 1 year in vacuum. We have to go from mile to light year and hour to century. This is your question number 1. Let me give you second question. Simple question. The Earth is approximately a sphere neatly a sphere of radius 6.37 into 10 raised power 6 meters. What's its volume? What is its volume in cubic kilometers? I repeat the question. Thus, this is approximately a sphere of radius 6.37 into 10 is about 6 meter. What's its volume in cubic kilometers? This is all for today. Thank you. God bless you. Assalamu alaikum.